Okay, everybody, last problem. Using the law of sines, remember. Okay, so what this is asking about is the depth of the submarine. So the thing about depth and that last problem, height, the altitude, is they're always the perpendicular distance. So it's asking about this distance right here, okay? And it's perpendicular. 1600 is that whole entire thing there. So what we're going to be solving for is right here. So once again, you have to work in the big triangle first and then work in either of the two smaller triangles. So I'm talking about this thing. You have to work in here first. So the first thing you want to do is find that missing angle. And the reason why you need that missing angle is because that's the side length you have. You have that side length here, so you need to know the angle across from it. So you're going to add those two together and subtract it from 180. Uh, 112. So this guy is 112 degrees. So I think you could set up a law of sines right here. You would use that angle, that side length. Now remember, when you're setting up a law of sines, right now you're looking at the big triangle. So half of your proportion is going to be sine 112 degrees over 1600. So you could use either of the other angles. So you could use that angle and you'd be finding that side, or you could use this angle and you'd be finding that side. It does not matter. I'll use 28 degrees. It truly does not matter. Okay, cross multiply. So I'm finding the side across from the 28 degrees, which is this one, because remember, we're in the big triangle right now. Cross multiply. Divide both sides by sine 112 to solve for x. You get 810.146. Okay, so I'm going to label that in the picture. Okay, so it's coming from there, that. There's what I used in the calculator to get it. Okay, so now you can work in the smaller triangle. You could use the law of sines also, but you can use regular trig because this is a right triangle. So I'm going to be finding that. I know that's 40 degrees, so I can actually do sine equals opposite over hypotenuse. So sine of 40 degrees equals d over that thing. Okay, so just think about the triangle here. This is a right triangle. That's the hypotenuse, okay, and this is the distance you're trying to find. So you can use regular trig. You can also go back to using the law of sines too, you guys. It does not matter. Law of sines works in a right triangle as well. So d over, so sine of 40 degrees, look at the small triangle, equals d over the hypotenuse, which is 810. Okay, so how you solve that is you do d equals 810.146 times the sine of 140. Or I'm sorry, sine of 40. And it's rounded to the nearest foot. So I use the unrounded version, so I just did this times sine 40 degrees. So you get 521 if you're rounding to the nearest foot. Okay, this is the law of sines, everybody. There's a couple application problems in the homework, but it's more solving triangles. Take care.